first you should be clear that actually, if you look at this question, you have to make the free body diagram. So of this, the the P, there is, it's on a smooth pulley. So a smooth slope. So P will only have a component of weight mg sine theta. And that theta, sine theta can be found out by uh, perpendicular over hypotenuse 0.7 over 2.5. So this can be found. There will be a reaction which will be mg cos theta, but that's irrelevant because F is mu r works only if there is friction. Reaction is required there. Mg cos theta is required there, but there's no mu is zero, so not required. If you see this body, there is another tension force acting here. Now, on this P, there is a force acting here, mg sine theta. There is a tension acting up. The and on the body Q, there is a weight acting downwards and there is a tension acting upwards. And he says this 2.5 and 0. The masses are given. So this is 0.5 into 9.8 into sine of whatever, 0 sine theta. Now, both these are released and then it starts moving. So that means this will start going down is causing ma, and this is going up, it is causing ma. So what is, if you see these previous questions here, like equilibrium force and equilibrium questions, is that same body P. There's nothing, these questions are not different. It's just forces acting and finding the resultant causing an ma. So these type of questions and that question is the same. Only difference is that you are connecting two bodies, the tension in both of them are related. But it's the same question. Well, like these type of questions which come, don't think this is like uh, P acting P. This point is P, you know. So it could be, but they have not connected it to this. Let this be tension, you know. So that tension is to another body. So don't think of them as separate questions. They're just one type of. Anyway, then T is equal to ma, and we say mg sine theta, it must be greater, minus T is ma, and here T is equal to is going up, ma is equal to T minus mg. And then these two T you can add, and you can get substitute and get acceleration. So that after you get the acceleration, this is going up and here it comes, and when it comes here, the object Q comes here. This is at till that time that acceleration is valid. Once this breaks, then whatever was the velocity at this point and this velocity at the fully is 2 meters per second. So that velocity you will get, and you will get, that will be u. You will get a velocity. You can always you can calculate. You see, the acceleration we know. So till the time here 0.7 distance, v square minus u square is equal to 2 as. So the distance is 0.7. Acceleration we know from this equation, u was 0, so v we will know. So at this point that v comes here. Now after that it becomes, it follows not this acceleration a, because now the string has broken. It follows acceleration g, mg g sine theta. Now that means I know the final velocity, I know the initial velocity, I know g sine theta, so I can calculate the distance s. Now this distance minus the total distance will give you the string length. Because you see at this point when the string was here, this was the total string. After that it increased its velocity from some value here to some value here. So that distance you know, because you know the acceleration, and the acceleration here will be a, here will be g sine theta, because after the string breaks, this a is not valid because the body has gone away. So it's just falling under free fall, mg sine theta. So let me show you the answer. Hold on. This uh, till the time, देखो this sine theta we know is 0.7 by 2.5 now. So mg sine theta minus t is equal to ma is the equation for of p na. So this is what he's doing here. This is what he's doing here. He's doing 0.5 g into 7 by 25 minus t is 0.5 is 0.5 is the 0.5 is the mass of p. Hmm? Okay. Then for this, this is the second equation that is going up. So um, this would be t minus 0.1 is equal to 0.1 a. This is 0.1 pq. Okay. So t minus 0.1 g is equal to 0.1 a. So he gets these two equations. Okay. And he solves. He gets acceleration is 2 by 3 and the tension is this. Okay. Now, this pulley reaches the top, when the pulley reaches the top, it, it must be having some speed, you know, when this goes up. So for that, he knows the distance. So he calculates the v is equal to u square plus 2as, and u is 0 because the string, it was released from here and it goes to the top. Okay. So acceleration is 2 by 3. Acceleration is 2 by 3 and distance is 0.7. 2as. A is this A is here, no? The same. So this is the velocity of the part of P at is going down. P when it's going down at this position, when this has reached up. So P is going down. This has reached up, this string. P would have come here and it is going with the speed of how much? This much. This. Uh, the speed is not given the speed, but it is. Uh, he's using this as u square. Okay, whatever he's got here he putting here, and v square is equal to u square plus 2as, right? So v is 2, the end speed, right? V, the so that is 2, he said, no, he said it's 2 here when it reaches here. Yeah, so that means it traveled some distance from this speed to this speed. That distance he is calculating this. Notice he's using acceleration is he's using 0.28 g. Now why is this 0.28 g? Because this is mg sine theta. So m is removed. So sine theta was g was how much was g? 9.8 and sine theta was 7 by 25. Na? So what is um, 9.8 into 7 divided by 25? 0.28. Okay. So this is 0.28. So he's when it's going down, the acceleration acting is mg sine theta, na, just g sine theta. Okay. So he's calculated this distance. The distance comes out to be s, this, and then he puts it here, and he subtracts that distance from the, because this was the total 2.5. The string is here now. When so this is the string length. This is the string length. This is s. So 2.5 minus s is l. That's what he's doing here. Length of string is 2.5 minus s. S is the distance where it increases speed from this value to 2 value with an acceleration which is different from the initial acceleration, because now the string is broken. It is not 2 by 3 now. It is this because it's falling under its own weight. Did you understand? Hmm?